Okay, number one on our list is parameters. Many people don't understand that IronCAD is a true parametric modeler, and we'll show you how we can set up a very simple example of that. Alright, so the first one we do, we have a scene open. I'm going to just drag and extrude in here. And what we want to do is assign parameters. When you hover over the handle, it gives you a little icon there. It shows you a L. This one's a W for width, H for height, right? So we want to add parameters for each one of those. And how you do that is simply right click on it and say create a parameter. And what I typically do is I put a F in front of the name, only for my own sense that I know that that's a feature level parameter. Okay, we don't have to worry about the value yet. And we'll do the same for the width. Create a parameter. And I'm going to use this handle on the height since it's extruding in this direction. So we'll right click on here. And so what we did here now is we've created the parameters at the extrude level. Okay, the feature extrude level. And now we want those to drive, actually we want to assign a part, connect them to part level parameters. And how you do that, so we'll right click on the part and go to parameters. And then we'll come in here and add parameters. So we're going to say long. I'm just putting arbitrary numbers in for now. I'm going to add wide. And we're going to add high. Okay, so you see we have our 3 part parameters here. Okay, now they have to drive the extrude features. So how do we connect these parameters to the feature parameters? Being that we have this part selected, we just say show all the parameters on that part. So it'll drill down, and here you can see the extrude parameters we have that we entered. And you just simply copy the name into whatever field you want to drive. So if we want to drive this length with the long, we type in long here. And we'll do the same with the other ones. I want the width to be driven by wide and the height to be driven by high. Let's say apply, and there you have it. You have now a parametric part. You can come in here and change at any time. You don't really need to see these anymore. And you can come in here and change the values at will. And there you go. Now we can take this, create parametric parts where you're driving all sorts of things, other features, other parts, other assemblies. I just wanted to show you a quick example of how we create parameters. Hope this helped you out. Okay, number 2 on the list is using open profiles to create spin shapes. We'll go through our feature, and I want to do a spin wizard. And I'm just going to pick anywhere in the background. We're going to make a regular part. And what you want to understand is that the y-axis is always the spin axis, the green one. So what's nice with IronCAD is you can come in here and you can start drawing your geometry however you want. Okay. And let's say that's what you want. Maybe you want to drag that like that. Being that this is the spin axis, IronCAD will automatically close the profile for you. It'll just generate the endpoints right to that, however you want. So when you say finish, it's created the spin for you. So when you go back into the cross section, you see it added the necessary geometry. So just a quick way so you don't have to worry about closing it all the time, and this only works on spin shapes. Okay, number 3 is using our dual kernel technology. Many users don't understand that IronCAD had developed the ability to use both the ASUS and Parasolid kernel to do all its modeling. It's the only CAD program on the market today that does that. Everybody's still baffled how they were able to do it. But the beauty of it is whenever you get stuck on something, you can always switch kernels. They're both working with you at all time, but you can always make which one's the primary. So in this case, we ran across this. We did a sweep of this handle here, and if you look at it, it's in the ACES kernel right now. Okay, because what happened is we usually use parasolid. So when it was in parasolid mode, it failed. They couldn't figure it out. I guess it's a weakness of that kernel. So if you're in a parasolid based program, you're gonna have to do a little work to work around this somehow, right? But in IronCAD, no problem. If it failed in parasolid, we just switch to ACES. ACES has a better algorithm for doing this and solve the problem for us. So there's so many benefits to be able to use these dual kernels. They're endless. Okay, number 4, designing in a traditional approach. Um, let's get started. If you want to work like you do in any other program, whether it be SolidWorks, Inventor, you name it, and you want to follow that routine of creating sketches, extruding, and working in a traditional approach, IronCAD does do that. You do that under structured part mode, which we already set because we have 2 modes. And then you can come in and start doing your sketches. Okay, I'm just showing you the approach to doing it like you would in any other program. I'm just going to draw a box. Okay, you have your implied constraints. You can apply the constraints if you want at any time. I'm just doing everything in one shot here for the speed of the video. You can come in and start applying dimensions to these if you want. Okay, again, this is more traditional. Maybe you want to position this hole ½ inch from here, and maybe 3/4 from there, and the diameter of that hole you want to be 0.38. Okay, so there's your traditional sketching. And again, I'm not showing you everything. We just finished that sketch, and now what you want to do is extrude it, right? So we'll go up to feature, and then we hit the extrude, and then we'll ask you, do you want to create a new part? I will. And then we just come in here and pick that feature, and you can say how deep you want it. Do you want draft, blah blah blah. There you go. And that's a traditional approach. Now be aware, this is the hard way of getting there. I'm not showing you the optimal way of using this approach. I just wanted to show you that if this is the way you want to work, IronCAD will certainly accommodate you. Okay, number 5, opening up DWG and DXF files. Very simple. Just simply go open the file, put your filter to DWG DXF, and we'll just open up an assembly here. And the only thing to note here is in the menu button down here you have an open option. Since IronCAD has 2 drawing environments, you can pick which one you want. We recommend the Casa Draft. That's more or less like an AutoCAD type clone-ish environment. So we'll use that one. Say OK, open. Okay, I don't have the fonts, but no worries. And there you have it. Now you have the drawing. It comes 100% in. You can come in here and edit as needed. It comes in with its blocks, whatever the original issuer set it up for. So very simple. You see you got the same. You can edit and save these drawings even if you do them in IronCAD as DWG or DXF. Okay, number 6, line to arc transition. This works only with the polyline tool. Alright, so we're in the sketch mode. Let's get our polyline tool. And I'm going to just start drawing some lines. Straight lines, but here now I want to arc. I kind of just hold it. I snap it to the middle one up there, come over here, come to the end point here, and then draw a curve I guess from here, up, over, down, here, and there. Alright? So it's a quick way, by just holding when you're dragging in the polyline, it will convert to an arc. Alright? Hope you find that useful. Okay, number 7, catalog sets. For design teams, users, whoever you want to set up. Nice thing is, I'm Tom. I come here to the IRONCAD. I share this license with somebody else. And they left all these catalogs open that I never use. You can see down here, I don't use any of these. What the hell does he use so many catalogs for? So I want to set it up now for me to use, so I can come here and go to the Commons tab, and under the catalogs ribbon, say close everything he's got open, and then we'll go back and then go to catalog sets and then open my set that I have created here. So open that, nice and neat. I only use a few, and I'm like, you know what, maybe in this round I want to add some rendering catalogs too. So somebody had created that and added those catalogs as well, and we're done. And now I can start using my predefined catalogs. Alright, so the catalog set tool is very easy to use. It's pretty simple. You want to create a new one, you hit a new one, Fred, and then you can come here and add all the catalogs you want to use by simply going and hunting them down. Say OK, and when you're done, you're all good, and now it's available for you at any time. You can open that and it opens those. And again, if you just want those open, go out and close everything. Hope you find it useful. Okay, number 8, spinning the scene. So if you just want to rotate everything that's in the scene, you can go to your animations and hit a height spin. And then if we go to our visualization and turn it on, you can see everything spins in the scene. You can adjust this timing and everything of it by the Smart Motion Editor and making it longer here. Okay. And if you play it, it takes longer to spin. And you can do other things with your 3D mouse while it's doing that as well, to give full effect. Okay, hope that helps. Okay, number 9, mating and positioning parts without constraints or the tribal. Little people know that this is a little hidden tool that can speed up the process for you. So for instance, let's say we want to align this cylinder flush on this surface and in the center of the hole here. Simply select the part, and up here on your tools there's mate and align positioning. So what that does is allow us to pick key points, and you see it gets a point and a direction. So let's say we're going to pick this, and then when you come over here you see you get a highlight. You can pick on the face, or you can pick right to the center and hit the tab key. It'll toggle which way you want to go. We'll do it like that, and you're good. Okay, and that works for basically any parts. You get the same thing going on. Alright, I think we said okay to that. Alright, now we're going to pick this part and do the same thing. You got, let's say you can hit points, edges, faces. I'm just going to pick the midpoint and that face, and we're going to put it over here, or maybe we want on the center of this hole here, or maybe on this edge, you could see. And again, hitting the tab key is a quick way to position it. So get used to playing with it. It's a very good tool to use to get you not always having to rely on the tribal. Okay, number 10 is a really nice ability for conceptual modeling and even actually engineering when the need arises, and that's the ability to cruise shapes on a part. And what that basically does is you can drag any shape in onto a part, and it has by default behavioral intelligence to know how to stay attached to that part. So when we drag, now we can simply left click and drag and move this part anywhere we want on that part. We can move it on this side, we can move it over here, we can move it to the bottom if we want it. We can even move it along blends. Let's say you want it right on the blend like that. Okay, maybe you want it on the cylinder, you can move it on the cylinder. It knows how to stay on that part at any time. Now you can right click and do the same thing, and what that does is obviously give you options like linking. So if we change one, right, they both change. So also another nice thing is if you hold the shift key down, let's drag another part on here. We'll stick with a cylinder. You drag and you hold the shift key, it'll snap to, it'll see the edges to snap to. If for instance you want that perfectly adjacent like that, or maybe you want to center it on the corner, you can hold the shift key and it snaps right to the center like that. You can snap to edges, okay, so it's perfectly tangent. That's simply done with the holding the shift key while dragging, okay. And again, this is what we refer to as cruising. You'll find nice and cool ways to use this approach. It's extremely useful when you're conceptualizing some designs. Okay, number 11, duplicating features or parts with point clicks. Okay, simple to do here is, for instance, on this part, let me move this part down a little bit so we can see what we're doing here. Okay, so what I want to do is copy these two features. There's actually two of them here. There's a cylinder and then a top cylinder, and I want to copy them to the other three holes. So the easy way to do that is we'll select the two features holding the shift key. Okay, get your tri-ball, and now it's going to stay along the same plane. So what I want to do is right click on the plane, that top plane 2 that matches that, and say right click, create multiple copies of links, and I want to create links. So if I change one, they all change. And from here I can't get to the center of the hole, right? So to get to the center of the hole, you got to hold the shift key and click it, and then we'll do it again here, click that center and click that one here, and there you have it. Okay, so we were able to just click that. With being that we couldn't get to the center of the hole because it's a through hole, we had to use the shift key. So here, well, we want to do the same thing with this hole here. All right, and they're gonna go copy to all these rivets. Being that there is a center to the to these rivets, it's a little bit easier. So we can just get our tri-ball, do the same process. We want to do it along the same plane, and I'll tilt this so you can see it. Right click and say create multiple links, and this here you can just pick right to the point. Actually, we did that one already, so we'll just delete it. And you come here and there you have it. Very simple, quick way to create duplicates of your parts. Okay, number 12, min-max dimensions. Certainly there's times when you need to know what the minimum distance or the maximum distance is between two parts in a scene. So we have two of them here, and how you do that is you go up to the annotation menu and the measurement tool, click this first one here, and then you just gotta click it and click the pick the two surfaces, and you see it's set to give you the minimum 1.12, and it also gives you the X, Y, and Z. Zoom in. If you want to know what the distance from that surface to the maximum of the first part, you can do that. You see it gives you 3.37. Or if you want to do maximum on both parts, you see it gives you that as well. Alright, hope that helps. A little tip. Okay, number 13 in this series, replacing parts with a simple drag. Alright, very simple in IronCAD, since we do everything in a single scene environment. You see we have an assembly here, bunch of assemblies, parts, everything's done in one scene. So, for instance, we're looking at this feed box here, and I want to change this pulley to a single pulley. Right now it's double, and I want to see what the single pulley looks like on it. So the process for replacing a part is simply highlighting the part and then coming into your catalog and finding the one you want to replace it with. In this case, I want to replace it with this one. Just hold the control key. That's it. Holding the control key, you drag right onto that part, and it replaces the part within that assembly. Okay, because we selected that part first. If you want to replace an assembly, for instance, if we come up here, this is an assembly. You can see it's highlighted by yellow, and I want to replace it with a more square type of design. Hold the control key and just drag that in there and replace it. Very easy to replace parts. If they're externally linked or anything, it's not a problem. If you want to replace assemblies with assemblies, parts with parts, parts with assemblies, vice versa, simple, hold the control key down and drag your parts in. Alright, hope that worked. Hello, number 14 in this series. There's times when you want to redirect your drawing to a new 3D file. In other words, we used a file to create this drawing and there's an internal link to it. Maybe you want to relink to a different file for whatever reason that may be. So the quick way to do that is, while you're in the drawing, you simply hold the Shift, Control, and L key, and what that does is it tells you the file it's already linked to. In this case it's 14A, and we want to link this drawing to scene 14. So you select it, say change source, and come back and say relink it to file 14, say done, and it updates the drawing for you. Okay, very easy. Remember, just changing the source file is Shift Control L. Okay, number 15, direct face modeling and maintaining feature structure of that. A lot of people don't realize that you can do direct face modeling on a part and continue to edit those as if they were IntelliShapes. So how that works is that only works when you're in structured part mode. So I've created a structured part already here with a block. So now let's say we want to move this face. So we pick that face, we say move, right? We get our triball and we'll just move that out for argument's sake 0.5. Okay, say okay, and you see now that move shows up as an IntelliShape in that part that you can come back and edit at any time and say you really want to redo that move and do whatever you want to do and say okay. So that's a nice feature in structure mode, is that any direct face modeling modification is tracked in your structure of your part. Hope you find that useful. Okay, number 16. Using Windows Explorer to open files or import files. Very simply, we have IRONCAD open here, and from Windows Explorer you can drag in any type of file you want. They could be STL files, any neutral data, actual IRONCAD data. So for instance, we could just drop the scene in and it loads for us automatically, right? Now in this case, we can also come to Windows Explorer and say I want to make this piece out of cork for obvious, just to be a little cute. Well, we can drag that on right onto the part and it'll ask you, how do you want that to apply? Is it a texture, a bump map, a decal? We'll just pick it as a texture, and there you got it. Simply dragging and dropping from Windows Explorer. If we open up a new scene, actually we don't even have to open up a scene. Let's exit out of everything. We're going to exit, and go back to our window. We don't need this. And we want to import a file. Well, let's say take this STL file and simply dragging in as well, and IRONCAD will open that. Okay. So you'll find that it becomes very useful sometimes if you happen to be looking for something, and rather than launching the program, opening the file, you can simply drag those in. Hope you find that useful. Okay, number 17, creating geometry from planes. Alright, there's two ways you can do that. You can do that through your global coordinate system or through section planes. We'll show the first here. So what we're going to do is, let's say we want to cut along the XZ plane. We can come here and unhide this plane. And if you don't see it, that means you'll have your coordinate system visibility turned off. So we'll turn that back on by right-clicking, go into show, and turning those on. And there's your plane, and the other two are still hidden. Now what you can do is you can right-click on the system, coordinate system, format them, and tell them to automatically size to your part, which they do. So now to get the geometry that plane intersects, you simply right-click on the plane, and you say create section profile, and there you have it. It creates the geometry for you. If we hide everything, you can see there it is. We don't need that, and you can use that any way you would normal geometry in IronCAD. You can also say, I don't really want the that to go through the whole part. Maybe I just want to pull it, the plane, to about here, and that's really only where I need the geometry from. So you can right click on it and say create, and it'll only give you the geometry wherever the plane intersects. So if we edit that, you can see you have that geometry. You can edit any way you see fit. Okay, so another way to do that, that's the way you can do it with the datum planes, or the coordinate system planes. I'm just going to turn them off for a minute, so we don't need any more. Well, let's say you need a section maybe through the center of these two holes. Those are not on any of these planes, so an easy way to do that is you select the part, you come up to the tools and section the part. And now that the part is sectioned, you can drag it to where you need to. Okay, you can snap it there, and you can rotate it, and now you want it to snap perfectly to that hole. You just grab the inner handle and snap right to the center, and there's your plane. You have the section plane, which shows up basically as another part in the scene, and then you can simply right click on that and say create section geometry or profile, and there you have it. Those are the two ways you can extract geometry from planes. Alright, moving on to 18, Bi-Directional Associativity. This allows you to update your 3D models from the dimensions you have on your 2D drawing. If you look at our drawing here, I just placed these two views, and I'm just going to add just a simple dimension to it, just so you can see what's going on. So I added a dimension. That dimension does nothing. All it does is annotate what we have in 2D. To get the dimensions that drive the 3D model, you go back to the model. In this case, if I want to drive the outside shape of this block, I'll pick it, go to its cross section, and in here I'm gonna add a dimension. Say OK, and add a dimension here. Say OK. The corners are already locked to be perpendicular, indicated by the red indicators. Now, how do you get this functionality to work? The real trick is just to right click on these dimensions, say transfer to drawing. Puts a little tick mark on there for you. Say OK. Now if we go to the drawing, we will update, and you see it put those two dimensions in for us. And you notice when we hover over this dimension, nothing happens, but if we hover over these two, you see you get your double red outlines indicating they're driven back to the 3D model. So if we right click on this and say edit, let's just double it, say OK. Alright, say that's good. We go back to the model. This drawing will not update to it. You go in here and see what happened. Once you see what happened, then you come back and the drawing will update. It's kind of a safety to make sure you're not interfering with other parts or anything. We'll do the same thing here. Edit this dimension. We'll say 4.375. Say OK. We got to go and see if it... Whoops, I forgot to say check. Oops, OK. We'll go back to the scene to take a look. Alright, everything looks OK. We come back and say OK to update the drawing. And that's how you basically drive your 3D models from your 2D drawing. Okay, number 19, multiple coordinate systems. There may be cases where you need to reference specific key points in your design. So IRONCAD certainly allows you to do that. Beyond having the basic global coordinate system, you can assign additional ones. And how we basically do that is you come up to your structured part catalog and you say coordinate system, and then you have a way to set up your coordinate system here based on various parameters, but I'm just going to say point. You can also key it in if you want, and I'm just going to say right here is my key point, and it's telling you, do you want to see the global system? Yes. Okay, so we see it there. Alright, and it gets listed in our scene browser here. We can rename it if we want. I'm just going to say number 2. Okay. Now, if we have our position dimensions on, as we did in number 20, if you pick a part, you see it's still referencing the original coordinate system, but maybe we want to reference this system. Simply activate that. Now when you click the part, it's referencing the new coordinate system. Okay. Now at any time you can come in here and hide all inactive planes. Actually, you can hide here. Just hide these if you want. Create another plane. I'm going to use the same approach and pick this point. Alright, and we're going to rename this one to number 3 and make that active. So now when we click that part, you see we're going to that hole. If we make this active, we're going to this hole, and if we make the original one active, now we're going to that. So a great way to create multiple systems should your need arise. On the list is the ability to position a part or assembly in relation to the global coordinate system, or the origin point 0, 0, 0. So in order to do that, you simply go to the Common tab, Display ribbon, and under the Smart Dimensions drop down, hit Position Dimensions. Now when we select the part or assembly, you see we get these dimensions relative to our origin point here. Okay. Now you can double click on them to edit them real easy to reposition your part. These position dimensions are attached to the anchor of a part or assembly, and that's where it'll draw these dimensions from. So if you wish to have a key point on your part from which to derive these dimensions, simply click the anchor using the tri-ball and drag it to the desired point, and you can see now your positioning dimensions are based on that key point of that hole, where you can come in and continue to edit.